Last time we were looking at the controlled cause-to-effect experiment. To briefly recap that, the basic idea is this. In a controlled cause-to-effect experiment, the people conducting it know what the cause is they wish to test. What is at issue is, what is the effect of this known cause? And as we saw, the process is pretty straightforward. You have the population you're concerned with, and you pull out a sample from that population and divide that sample into two groups. One group being the experimental group, which is exposed to the cause, and then the other group is a control group, which is supposed to be matched against the experimental group as closely as possible, with one important exception. The members of the control group are not exposed to the causal agent in question. Then the experiment runs its course, and the results are examined. And what those conducting the experiment or assessing the results look for is to see if the results are statistically significant. And what that means, basically, the results are statistically significant means that the difference between the experimental group and the control group is different enough that it shows there's most likely, a causal connection. Now, as you can see from the table here, which I saw previously in class, a very small group, 10 people in the experimental group or 10 whatever you get in the experimental group, matched against a control group of the same size, the difference to be captured must be 40% in order to be considered statistically significant. This is because with small groups, you can have wide variations that are due to chance rather than the causal factor being in play. So, for example, if a weight loss company reports that in a controlled experiment, members lost 30% more weight in the experimental group than the control group, and if you find out that there are only 10 people in the experimental group, well, those results could be entirely due to chance, because a group that small would only be able to capture differences of 40% or more. And as you can see from the chart, you get better and better results. You can capture finer and finer differences as you increase the population. So going from 10 to say 100 results in the ability to capture something 13% or more. And similarly, if you get to 1500, this can detect fine differences, which is why it's important to have, just like with generalization, a sample size that is large enough and also representative. Now, turning to the new stuff, what about cases where, when you're testing, say, human populations, in cases in which it would be impractical or unethical to engage in a controlled cause-to-effect experiment? For example, an ethical person wouldn't want to infect people with, say, a virus to see what it does, or expose people to tobacco smoke to see what it does to them. However, we do wish to know about what such bad things do, and so we do is we conduct studies, specifically two types: the non-experimental cause-to-effect study and the non-experimental effect-to-cause study. We'll begin by looking at the non-experimental cause-to-effect study. Here's the basic idea. It's similar in many respects to the controlled cause-to-effect experiment. The difference, though, is this. First, in a controlled cause-to-effect experiment, the experimental group, those exposed to the cause, are not exposed to the suspected causal agent by those conducting the study. Rather, they're exposed by their own actions or perhaps circumstances. So in a non-experimental cause-to-effect study, what occurs is this. Those in the external group have been not selected by those conducting the experiment in the sense of being exposed to the cause. They've already been exposed to the cause by either their own actions or circumstances. And the question is the same as in a controlled cause-to-effect experiment. Namely, we know the cause, what effect does this have? So, as the name implies, the cause-to-effect study, the cause is known, the effect is known. So the objective is to determine the unknown effect of a known cause. But it's non-experimental, which means that those conducting the study do not introduce the cause themselves. It's introduced by some other factor. Either the people involved or whatever is involved expose themselves by their own actions, for example, by choosing to smoke, or by circumstances. For example, if they're studying the effects of radiation after the tsunami that hit Japan, there'd be people exposed to radiation by the circumstances that damage that reactor. And so the objective is to determine the effect of that known cause. Now, another difference is that in an experimental group, in this case, is randomly selected individuals who have already been exposed to that agent, which can lead to some problems. One problem is, of course, is that those involved might be self-selecting. That is to say, they can be doing things that put them into the experimental group that also affect the results. For example, people who have a fatty diet will often tend to drink more alcohol than others. So a study of people with fatty diets will tend to include more drinkers. So the results of the study might be due to the alcohol and not just the fatty diet. Now, so it's important when sorting out the study to try to ensure as much as possible that the way in which individuals self-select themselves in regard to the cause not be biased in any way related to the effect. So the idea is basically to try to select the samples carefully. For example, if there's a study involving fatty diets, to see what effect that has on people's health, the investigator should make sure that, say, the number of drinkers and smokers and so forth are the same in both groups. Because using that example, someone who eats, say, poorly might also have other poor health choices, and those you'd want to control for those. Now, if there are any relevant variables that have not been controlled, then those would raise doubts about the correctness of the findings. So, by the very nature of the study, they were weaker than controlled experiments, because in a controlled experiment, those conducting the experiment are much more, controlled. They select the experimental group, they select the control group, they introduce the cause, observe the effect. In the case of an experimental cause-to-effect study, the goal is to determine the effect, but those conducting it don't introduce the cause, and they essentially have to take whatever they get in terms of people self-selecting, say by smoking, or by circumstances. Say people just happen to be living near a nuclear reactor that, starts spewing radiation. Now, the second one we'll look at is known as the non-experimental effect-to-cause studies. Now, these differ from the previous two in important ways. Their goal, though, is what makes them different from the other two. In the cause-to-effect experiment and study, the cause is known, the effect is unknown. In the non-experimental effect-to-cause study, it's the exact reverse. Namely, the effect is known, but the cause is not known. So the objective is to determine whether something is a causal factor for an effect. So effect known, cause not. So the difference between the non-experimental effect-to-cause study and a experimental, control cause-to-effect experiment is this. First, the experimental group already displays the effect. The control group doesn't display the effect, and you're trying to sort the difference between them to find the cause. So at the heart of it, two main differences. One, the inquiry is reversed. Instead of going from, I know the cause, what's the effect? It's, I know the effect, I wonder what the cause is. Secondly, obvious enough, in the control cause-to-effect experiment, those conducted introduce the cause. In the non-experimental effect-to-cause study, the cause is introduced by something else, and the effect is known, but the cause is not. Now, in the case of the cause-to-effect study, the differences between the non-experimental effect-to-cause study and the non-experimental cause-to-effect study is, again, a reverse of the goal. In the non-experimental cause-to-effect study, the cause is known, the effect is not. In the non-experimental effect-to-cause study, the effect is known, but the cause is not. Now, as might be imagined, finding that the suspected cause is simply more frequent in the experimental group is reason for saying that the suspected causal agent is a causal factor in the population involved. But it's worth noting, and very important to consider, that the subjects in the experimental group might differ in some important way from the rest of the target population, and these factors must be controlled. Here's a concrete example. People who are former smokers are more likely to use chewing tobacco, and also more likely to get cancer of the mouth. So, a sample of people that are exhibiting cancer of the mouth would thus tend to include more ex-smokers than their general population, and hence more tobacco chewers. Hence, it might be concluded that chewing tobacco causes cancer of the mouth, even if it really doesn't. And so, it's worth noting that, as a general point, that those who are exhibiting the effect might, differ in some other important way that affects the result. And so sorting out the cause, when all you know is the effect, is rather difficult. Now also, such studies only show the probable frequency of the cause, not the effect. And so they don't provide any grounds for estimating the percentage of the target population that would be affected if everyone were exposed to the cause. But in many cases, all we have to go by is the effect, usually something bad like a disease breaking out or some illness or something terrible, and so we have to use this method in such cases. Now, one way to avoid the ethical issues regarding testing and studying humans is to use animal testing, because people often believe that it's okay to do to animals what they regard as morally wrong to do to people. Now, as might be imagined, this also raises ethical concerns as well. If we decide to do to an animal, to test some chemicals or something on an animal that we regard as wrong to test on a human, that does raise a moral concern. But for those who are willing to regard animal testing as morally acceptable, laying aside the ethical problem, there's still a problem for the critical thinking aspect, namely this. If we conduct an experiment on an animal in order to determine what it would probably do to a human, we're engaged in two levels of induction. The first is, of course, engaging in the control of cause-to-effect experiment, which is inductive, which means that even if you do everything correct and properly, the conclusion could still be mistaken. Secondly, if you're going to take the results involving, say, the monkeys or the rats and extend it to human beings, this requires an argument by analogy, and hence that is also an inductive argument, which leads to the problem of, again, even if all your reasoning is done carefully and all your premises are true, your conclusion could still be mistaken. And so that brings us to the end of looking at the studies and experiments. And next, we'll turn to mistakes in causal reasoning.